Jim O'Donnell. He's a forest ecosystem biologist with the City of Austin's Balcones Canyonlands Preserve and has spent the last 14 years designing and implementing habitat restoration projects that are designed with an adaptive management framework. He's also instrumental in setting aside the City of Austin's Vireo Preserve, which once supported the largest concentration of black-capped vireos. I'd also like to thank him personally for leading field trips for the class I teach at Texas State University, the College of Rarity. We take students out there to Forest Ridge, and he's so excellent in shepherding us around. So, Jim?
Well, welcome, and thank you so much for having us out to do this. I want to thank the people who organized all this. This has been a great symposium, and it's been fun to bump into people I haven't seen in a while, so this has just been a lot of fun. Let me see if I can. Oh, there we go. All right. So our BCC permit, our BCC P permit compliance is that we needed to set aside 30,000 acres of land. About 2,000 of it was designed to be black-capped vireo habitat, and the remaining 28,000 acres or so is designed to protect golden cheek warbler habitat, and where we don't have golden cheek warbler habitat in those areas, we need to create it and get it moving. So, so existing and restore additional golden cheek warbler habitat. Get this microphone just right here. So we look at the restoration goals in three different sections. We have protecting our prime habitat, and the Balcones Canyonlands Reserve System has some beautiful prime habitat. We also look at areas that are kind of coming along, they're recovering. We call that, we're enhancing those areas. And then we have areas that are just really degraded. When you get a big ranch, like the ranch that I do a lot of work on, it's called Double J&T, it's 1,700 acres, and we've got some great habitat down there, but we've also got some upland areas that are extremely degraded. And so it's our job to kind of bring that back into something that's a functional habitat, and particularly aimed at golden cheek warblers. So this is just kind of an idea of a photo of different types of habitat. We have our prime habitat, and then we have recovering, which is kind of coming along, and then we have this real degraded stuff that because of land use history, it just hasn't looked any different than our first aerial photographs of the 1940s. Degraded habitat landscape, this is the caliche base that we deal with. When it rains, that water, it's like concrete that just washes right off. Any sort of little cracks and crevices are quickly filled in by little sediment pieces, so seeds don't really have a chance to germinate. And even if they did, you know, in the caliche, when it's 104 degrees, let's just say 100 degrees outside, it's around 120 degrees an inch down. So an inch down in that caliche is anywhere from 120 to 140. We were getting 140 degrees this last summer when we were doing these. In the juniper areas, in our woodland sections, it never gets out of the 80s. So quite a temperature difference. Before we do anything in these degraded areas here, we do a site assessment. And the site assessment is basically, you know, we do an assessment of the soil conditions, we look at compaction, we look at the structure of the soil, we look at the depth of the soil. Before we do any sort of digging, we want to know what's down underneath there. We also look at the geology of it. We're looking at drainage, how fast that water is going to infiltrate in that once we start moving some soil around. We look at erosion issues. We look at the amount of organic matter that may or may not be there. We assess the species diversity. We're looking for anything that might be sensitive in these areas. We're also assessing the amount of biomass and accumulated surface organic matter. How much is there? What do we have to work with? We start looking at the slope and the aspect. As we know that on the north side of things tend to do better than on the southwestern side of slopes. We researched the land use history. Why did it end up looking like this for the last 60, 80 years? And then we design a restoration plan based on all of that. So here's one of our sites here. This is the Double J&T site. And so we have a main access road coming down through it. It goes down to the river over here, the Colorado River. This is the upland area here. You can see here that we have these really degraded areas. And so we're looking at this as kind of precision restoration that we do have golden cheek warbler habitat down in the canyons here and on the slopes back over here and down in the canyon on this side. But what we want to do is connect all of that habitat together. So right now we've got all this edge effect here. And edges, as you know anything about golden cheek warblers or any sort of forest songbird, edges are dangerous places. So these are the edges that we deal with here. This is really degraded stuff. This particular property was first ranched in the 1850s. And the guy that bought this property worked for the railroad. Well, the railroad was coming to Austin in the 1870s, right? So the first thing he did was clear cut all of this and sold all of that timber to the railroad, okay? And that's kind of what they did back then. He's going to make use of what he has on his land. And then he was faced with an erosion problem and how to make money, so he turned goats loose on this property. And so then we lost all of the seed bank, basically. And they had this property from the 1850s up to 1946. Ended up selling this property for $25 an acre. This is in Lakeway, if you know where Lakeway is, just outside of Austin. It's much more valuable now. And so in looking at a restoration plan here, we've got kind of a restoration team, and one of our team members was able to get a water barn up here. It's 60 by 40. It collects 1,500 gallons per inch of rain. We run a poly black flexible pipe down along the road here. This is all downhill, by the way. And our restoration areas, we're kind of dealing with this one. We have about a mile of bioswales or berms and swales on this property. So we're kind of doing this area across here. Okay, so this area has been addressed, and you'll see pictures here in a second. We've worked in this area here, and now we're currently working down here. Okay, eventually we'll get over here, but we're trying to, again, to fill in these gaps. Okay, reduce the edge effect, and it won't be in my lifetime or yours that we have an old growth, warbler woods here, but we can start that process going. And if nothing else, we just start making it into a functional habitat instead of something that's 120 to 140 degrees in the summer. Let's see, I think of something. Keep moving here. That's way too fast. Okay, we'll try that again. There. All right, so this is one of the areas that's downslope there. It's on, this is an old borrow pit. To make that road that goes down there, for 100 years, they were taking soil off of the land. This is subsoil now, it's really not soil. And this is a borrow pit, and they were taking that and putting it on the land. And so this was a nasty little spot. I mean, it had erosion, had reels coming down off of it, head cuts going up it. And we have a contractor who was able to come in and shape the land on contour. And what he did is he created these little slight berms across here. And then just because this is hard pack, really hard stuff to get anything to grow in, we did auger holes in here for trees that we were going to plant so that the tree roots would have an opportunity to get down deeper into the soil, okay? And what we're planting here, this is restoring degraded patches to reduce edge effects with pioneer species. Pioneer species is the key word here. All of these plantings here are pretty tough, hardy plants. That's the thing in any type of restoration work. You put your hardy guys out there first. Those are the guys that are going to start providing shade. They're going to start improving the soil. They're going to allow for other life to start coming back into that system. And as a matter of fact, we had an American woodcock that was, of course, not so much here, but once it got better, we had American woodcocks come down because this will fill up with water after a rain. And it soaks in pretty fast. So we're collecting water on contour and letting that kind of plume into the berm. So you can see the recovery time here. This is, in December of 2022, and then, a couple of years later, we've got, or a year and a half later, we've got substantial growth there now. So as I mentioned before, we have contoured swales, berms and swales that we have in the system. This is kind of what it looked like here. And it's just like I say, 120, 140 degrees in the summertime. We're not getting much water infiltration here. We get spotty little grasses that might cling to something out here. And this is the same place, a couple of years later. This photograph was taken a long time ago. This is probably about 3 years old here, and these little terraces are new, but you see the swale coming across here, and we've got all these pioneer species in here. They're things like sumacs and any sort of legume species that we can get our hands on. And then we put a lot of understory, do a lot of understory seeding and a lot of mulching and stuff like that. And I can talk about where we get the mulch a little later, but so erosion is a huge issue out there, and it has been for decades, if not well over 100 years. And the erosion problem is so bad that no matter what you do, water will come down and kind of wash out what you've done. So this is a kind of a shout out to America Youth Works and Austin CCC that come out and do the heavy work here. And so these are fish scale berms. We kind of flagged it out here, and these guys came in and did this in a few days, collected rock. And the rock we collect, we call it the rock that's not busy. It's rock that when you pick it up, if there's nothing underneath that rock, okay, that's a good rock to use. If you pick it up and there's ants or a tarantula or a scorpion or something like that, it stays in place, okay? And they learned to do that, and this is a rock they collect. A lot of this is collected off the road. And over here, it's this fish scale berm. So what happens with water rushing down here, it fills in here. Now we've seeded all this. Now it's all Maximilian sunflower in there. Finches are real happy about that, and so are the painted buntings. So we're increasing the food source for other wildlife as well. But water comes in here, and it can seep through in a heavy rain. It seeps through these rocks. So it just captures it, slows it, and lets it spread down to the next available place. And if it makes its way all the way down here, it just goes into a swale. Okay, so water is slowed down, spread out, but it always has some place to go that's beneficial. This one over here, this is our armored terrace. Really, really bad area for erosion. This is actually a cave rock that we were able to use from a cave digging that we did on another property. So we were able to armor this up and then make little terrace beds out of this, and it now is full of plants and so forth. So our whole idea here is to slow, spread, and sink that water into the landscape. We want every drop of water that hits on our restoration sites to go into the soil, okay? So even in our wooded sections, this is a rock rundown. This is collecting water that's coming down off of a parking lot. So what it does is it slows up the water. We seed underneath here. So there's grass seeds and other seeds underneath here. I think we've got Mexican buckeye coming up over here. And so that slows that water down so it sinks in. If it goes even farther, it hits another one, sinks down. These are called rock rundowns. Sheet flow spreader. These are little U-shaped, sometimes called meta-lunas, half moon type thing. This was a rill coming down here that was developing a cut here. And so we put this little half moon spreader in here. That allows water to go through, but when it hits here, it kind of banks up a little bit and then slowly spreads out across the landscape instead of just hitting, on creating a channel. And then we use those brush berms that we were talking about earlier here, right? And so this area, this poor area here, this was hit by oak wilt, storm damage. It was just a really depressing area to work in there. But now we've taken that storm damage, taken some of those old oak wilt logs from the 1980s, and we put them on contour here. And one of our volunteers is very good at making brush berms. We call them fancy berms, and because they're artistically done, and very effective. And they slow down that water, trap that water, keep that moisture in the system, and we can seed in there too. That's protected. So this is a brand new project. This project right here is only like 2 months old. Okay. We call it the whiskey bottle because back in the days of cedar chopping, their lunch was not the nice little lunch we had. It was usually a can of something, or some can that we'll find that's all rusted, and there's an alcohol bottle. Okay, that's what they used. And there was a bunch of it right in here, so we just call it whiskey bottle. And so this is what it looked like, okay? Dry, harsh, it's difficult to get anything to grow there. And this is what it looks like now, okay? Not the same angle necessarily, but the same site. And so this is holding water temporarily, but right now it's just full of tadpoles. And when I came down there the day before yesterday, there was a great blue heron sitting there eating tadpoles out of the water. So, and we've put well over 100. This goes back about 1,000 feet back around the corner of this thing. This is a big project. This is well over a mile of this type of work. And kind of strategic places. You know, we're kind of doing, like I say, that precision restoration. And so we've got party plants in here. And that rainwater barn I was talking to you about earlier, we have that hose that comes down there. We have irrigation boxes down this area. So we can, because of the gravity, we can, gravity flow, we can attach a hose and water any of this stuff all summer. So that's how we keep them alive on those days or those where it's not going to rain for any length of time. All right, so we also use junipers as kind of bioactivators. The canopy, you know, the wind's blowing across junipers. It collects spores and pollen and dust, insect frass with the insects that are in there. And when it rains, all of that kind of comes down underneath into the juniper. The branches provide shade and protection and slows down, spreads the water. The diversity depends on kind of the diversity in the area. If you have a poor seed bank and there's not much there, you don't have much growing underneath juniper, which is one of the reasons why people think, oh, nothing grows underneath juniper. Well, it's because you don't have a seed bank really to support that. So in areas where we do have better seed banks, we often find 10 or 15 different species underneath these junipers, and acts as kind of a nursery. And we can build out from there. Sometimes we even harvest from here to move these to someplace else. It develops a nice little soil sponge underneath there, and one of the great things about juniper is that it is a pioneer species, but it's also a climax community species. And the water that is in organic matter can retain up to 10 times its weight, okay, in water. So organic matter is just, it's like a little sponge there, right? So when we go into those recovering forests, we're looking at kind of enhancing it by making sure there's a canopy. There's low trees and shrubs. There's a shrub layer, herbaceous ground cover, vertical layer, and fungal layer. All of those are components of a healthy forest. And functional diversity, we make sure that in these recovering forests, we have a lot of diversity in there, because the higher the diversity, the more insects you're going to have. And due to past land use practices, you know, we don't have a lot of diversity in these Juniper-Oak Woodlands lots of times. So it's what we're trying to do is to increase that diversity. Most insects can develop and reproduce only on plants that they share an evolutionary history with. And 90% of all those insect species are host specialists. So they need, like for example, this guy here, this is wafer ash. He's the host for tiger swallowtails and giant swallowtail butterflies. Who doesn't want that in your forest, right? So these guys are a host for that, so they need to be a component. And just an idea of the importance of a diversity of food in these systems. This was a study done by Doug Palamy's graduate students about, well, how many insects does it take to get like a chickadee, you know, independent, you know, a nest of chickadees? Between 5,000 and 9,000 insects. That's one chickadee family for one nest. Now think about all the wrens and cardinals and titmice and everything else. You need a lot of insects out there. And if we have areas that don't have a lot of insects because of lack of diversity, well, then you're not going to have as many bird species. And some of those areas you walk into and it's just so quiet here. Well, part of the issue is diversity. And just quick things like oaks, native fruit trees, and willows host the most diversity of insects. So you always want that as part of the component. And I'm
sorry, Jim.
Sorry.
Yeah.
And so golden cheek warblers need a lot of insects, and even our nest survival for golden cheek warblers, the higher the density of understory, the better survival. And that's pretty much it. Oh. We couldn't do this without a group of volunteers. So we have a lot of volunteer action here. And if you have a chance, this is my contact information. I'd love to give tours. Anybody wants to come and see all this stuff, there's a lot. And this, by the way, if you want our restoration plan, a lot more detail than I was able to do here. Take a picture of that, go to that, and you'll be able to get a lot more information. Thank you so much. Sorry.
No, that's good.